welcome back to The Explainer. Today, we're making a massive jump. We're going from those clunky procedural loops we're all used to, straight into sleek declarative processing with Java streams. So previously, we learned all about Lambda expressions and functional interfaces, right? Well, now it's time to actually use them. We're going to leverage them to process collections way more efficiently using streams. Let's set the stage with a classic problem we've all written 1,000 times, the traditional for loop. Say you've got a list of numbers, 10 through 40. You loop through, check if a number is greater than 20, and print it. Sure, this works fine, but here's the catch. It requires explicit control logic. You're essentially micromanaging the computer, and that completely clutters up your actual intent. Which brings us to a really fun pattern interrupt. Just ask yourself, can we express this exact same logic more clearly, entirely without manual loops? Enter the Java stream. Basically, a stream is a sequence of elements that supports functional style operations. The absolute magic here is that it allows you to process your data declaratively instead of manually writing out those tedious loops. Look at the difference here. When you use a stream, you just say list.stream, add a dot filter, and then a dot for each. Boom. You are explicitly expressing what to do, not how to do it. It reads almost like plain English, doesn't it? Now, under the hood, a stream essentially works as a pipeline, and every stream pipeline has three main parts. First, you've got your source, like calling list.stream. Then you have an intermediate operation, something like filtering. And finally, you wrap the whole thing up with a terminal operation, like for each, which actually triggers the process. Think of it like a restaurant order ticket moving through a kitchen. The data flows sequentially from your source, let's say a menu, right through a chain of those intermediate Lambda operations. It gets filtered, maybe mapped or sorted, before flowing perfectly into that terminal operation to give you your final dish, like a neatly packaged list. So why are we making this shift? Well, streams provide three massive benefits. First, functional operations, which we just saw. Second, drastically improved readability. But the absolute game changer here is lazy evaluation. That means operations like filtering don't even run until that terminal operation is called. The stream only computes exactly what it needs to, which is a huge performance optimization built right in. Now, if you only take away one thing today, make it this incredibly important rule. Streams do not modify your original collection, ever. Instead, they produce an entirely new result. No mutating state means no unexpected side effects, making your code infinitely safer. And because they produce a new result, you can easily stack common operations. You can take a list, fire up a stream, use map to, say, multiply every element by 2, then filter out anything over 20, and just print the results. You're doing complex data manipulation in one single, incredibly readable chain. The key insight to really wrap your head around is this. Streams fundamentally shift your programming paradigm from procedural loops directly into declarative data processing. You stop playing traffic cop with every variable, and you start acting like a director, simply stating the end goal. In the real world, you're going to use this stuff constantly. The most common use cases are exactly what you'd expect: filtering out bad data, transforming entire collections of objects from one type to another, and handling aggregation operations like summing up a total. Okay, time for a quick micro challenge. Seriously, pause the explainer for a second and try this. Take a list of numbers, filter out the ones greater than 50, and print them out using a stream pipeline. Okay, did you get it? It's just list.stream, .filter, I greater than 50, and .for each, system.out println. Super clean, right? So to recap everything we've covered today, streams provide a beautifully clean, functional way to process your collections. By leveraging pipelines and those Lambda expressions we learned earlier, your code becomes safer, faster, and just so much easier to read. In our next explainer, we'll keep this functional momentum going by exploring the optional class, and we'll see exactly how Java handles those dreaded null values safely. But before I let you go, I want to leave you with this. If declarative streams are objectively safer and easier to read than procedural loops, why do you think so many legacy codebases are still terrified to make the switch? Let that simmer for a bit, keep practicing, and I'll see you in the next one.